Hey everyone, welcome to 3.6 Complex Numbers Notes. So what we're going to do is work on solving quadratic equations that don't have x-intercepts but still have zeros. And I kind of mentioned this before, but those zeros are called imaginary if you can't see them on the actual graph, on the x-axis. And how these work is we need to find a way to take the square root of a negative number, because that's what was stopping us from finding them before. So we're basically making up a number that is negative when it's squared. This is called the imaginary number, or I. So we're going to use an I to represent it, and I pretty much means this. We know that we want I squared to be a negative, so I'm just going to call it -1 for right now. That means that if we were to take away the squared, we would have to square root both sides. So I really stands for the square root of -1. And this is basically the gist of what I is. I is the square root of -1, and more importantly, I squared is -1. Because we needed a number that when squared gives us a negative, because now I can multiply it by like 5. 5i would be the square root of -5. So then I can actually take the square root of -5 by using an I. And there are other powers of I that I'm going to talk about really quick, just to kind of show you how this letter works. And we're going to go ahead and do the next 5, 6 powers of it. So I third, I to the fourth, fifth, sixth, seventh, and eighth. Here's how I'm going to go about this. And before I start, I need you to know I'm going to put all of the answers up here afterwards. I don't necessarily need you to be able to repeat what I'm about to do, but just understand where these powers are coming from. So I to the third is 3 i's being multiplied. But the first two together make I squared because there's 2 of them. And I squared is just -1. So really, this is -1 times I, or -I. I to the fourth is 4 of them. But again, I squared is -1, and I can actually do that twice. So I to the fourth is the same thing as -1 times -1, which is just 1. Because for every time you put 2 i's together, that's -1. Remembering that I squared is -1 is going to be a really important piece of this lesson. I to the fifth has 5 i's, so I can make my 2 groups of -1s, which I now know that this whole thing becomes 1 because I to the fourth equals 1, just like up here. So every 4 i's makes a positive 1 because the -1 times the -1 makes a positive. But then I have this 1 times the I that's left outside. So that's just I. Then I can move on to 6. If I put 6 i's out there, the first 4 can still make a positive 1, just like they did on I to the fifth. But now there's 2 i's left outside, so we can go ahead and group those together to make -1. And then 1 times -1 is -1. So I squared and I to the fourth are the 2 powers that make whole numbers and can get rid of the actual I letter. I to the seventh is 7 of them. The first 4 make 1 because I to the fourth is 1. And then the next 2 can make -1, but there's still this odd one out now. So I have 1 times -1 times I, which is -I. Then, if I do all 8 of them, I can group the first 4 together, and then I'm actually just going to make this into 2 sets of 2, just to show you that it doesn't really matter. I could have made this into one big 4, which equals 1, or -1 times -1 is still 1. So I have 1 times -1 times -1, which is positive 1. And what we're going to find is that the powers start to repeat. Here we have just regular I, -1, -I, 1. I, -1, -I, 1. So these four are just a repeat of the first four. And if I kept going, I to the 9th would be I, and then I to the 10th would be -1, I to the 11th would be -I, and I to the 12th would be +1. And basically, if something is a multiple of 4, it becomes +1, like that. And we are going to use these powers of I to find other higher powers. Let me erase this really quick. Go. So what you can do is figure out what the remainder is if you divide the power by 4, because this pattern is 4 units long. If the remainder is 1, it's going to match this one. If the remainder is 2, it's going to match I squared. If the remainder is 3, it'll match I cubed. And if the remainder is 0 or 4, which is the same thing, it'll be this last one, I to the 4th. Because you are dividing the numbers by 4, 1/4 is 0.25, 2/4 is 0.5, it's the same thing as 1/2, 3/4 is 0.75, and if you don't have a remainder, or if your remainder is 4/4, that's a whole number, so you won't have any decimal. So you can look at the end of your number. For example, 34 divided by 4 is 8.5. That 0.5 tells us that the remainder is 2, which means it will match I squared, -1. So I'm going to take the power, like on the next one, 213, and divide it by 4. That gives me 53.25. 0.25 is a remainder of 1, because that's 1/4. So that means it's going to match I to the first, which is just I. 43 divided by 4 is 0.75, which is 3/4, so its remainder is 3. And I cubed is -I. 88 divided by 4 is 22, without a decimal at all. So my remainder is 4. My remainder is actually 0. The reason why I'm going to go ahead and call it a remainder of 4 is so that I know to come up here and use I to the 4th, which is 1. And that's how you can do any power of I. Divide the power by 4, and then match it up to these first 4 parts of the pattern. Now let's talk about simplifying. So simplifying square roots with an I just means you have the letter I with it. It's not really that different. For example, right here, the only difference between this and a problem we would have done in the first half of this chapter is that there's a negative underneath. And what we do is we're going to split that up by multiplication. Negative 121 is just -1 times 121. And this square root of -1 is just I. And then the square root of 121 is 11. So pretty much you can just make this negative into an I, and if you can do the square root of this number, do it. So now I have 2 times I times 11. I can multiply the 2 and the 11 because they're just regular numbers. And that makes 22I. Okay, on the next part, we have a negative 54. So I'm going to split that up into the -1 times 54. But then 54 doesn't have a nice square root. So what I'm going to do is find two numbers that go into 54, one of which needs to be a perfect square. 9. And 9 times 6 is 54. The reason why I'm picking 9 is because it is a perfect square and it's going to have a square root. And then my square root of -1 turned into an I. Okay, you can go straight from here to here once you get used to it. I'm just leaving this step in there so you understand why. Okay, so you basically understand that this is becoming the -1, or the I, sorry. Then the square root of 9 is just 3, like that, without a square root now, because we've already done the square root. And I can go ahead and multiply 4 times 3 because they're both outside now. I can't multiply the 4 and the 6 because one's outside and one's inside. 4 times 3 is 12, so I have 12i square root of 6. And then the third one on the top says solve instead of simplify. For this one, you want to get x squared all by itself. So I'm going to subtract this 37 to the other side, and that makes negative 32. Then I need to take the square root of both sides. And when I go to do the square root of 32, because it's negative 32, that's going to make a square root of negative 1 out front. That's going to turn into my I. You do not have to write this down every single time once you get used to it. And then 32 doesn't have a square root, so I'm splitting it up between 16 times 2, because 16 is a perfect square. I could also do 4 times 8, but you want the biggest perfect square that goes into that number, not the smallest. Then this becomes the I. The 16, the square root of 16 is actually 4, so that's what becomes the 4 outside, like that. And then you have the I, and the 2 didn't have a square root, so it's just sort of tagging along at the end. Now, one thing that's different between simplifying and solving is we had to add the square root into our equation. Whenever you do that, you have to add this plus or minus out front. So that means it's 4i squared of 2 and negative 4i squared of 2, which is something that we've talked about, but I haven't mentioned it for quite some time. Okay, and then I'm going to keep moving on to the next one. I think it makes more sense the more you see, so I'm going to keep explaining more of them. Over here, we need to get x squared by itself. We want to subtract the 70 first, which makes negative 120. Negative 50 minus 70 is negative 120. Then I'm going to divide by this 3. Negative 120 divided by 3 is negative 40. I have x squared by itself, so I'm going to take the square root on both sides. And this is going to become I square root of 40, because this negative makes an I. And then we have to split 40 up in between two numbers that multiply to 40. You want one of them to be a perfect square. In this case, that would be 4 times 10. And what's going to happen is I'm going to actually do the square root of 4, which is 2. This becomes an I, and the square root of 10 stays. And I have this plus or minus because it can be positive 2i square roots of 10 or negative 2i square roots of 10. Okay, moving on. Over here, I want to subtract this 50 from the 0, which makes negative 50. Divide by 2 on both sides, which makes negative 25. And take the square root. Now, there is a square root of 25. It's 5. But because of that negative, instead of saying 5, we're going to have to say positive or negative 5i. Okay, before, when it was just the square root of 25, we said 5 and negative 5. And now I'm saying 5 and negative 5i. This plus minus symbol just means you need both. Positive 5i and negative 5i. It's a way of just writing the answer a little bit simpler. Then we need to move this 7 to the other side. So we're going to add 7 to both sides, which means I have 7 plus 5i and 7 minus 5i. You always want the problem to end with the i's at the end, which I'll explain a little bit more as we move on to the more operations with it. But you always want the whole number without an I to go in the front. And since this is going to be a positive 7 because I'm adding it, it's a positive 7 here. All right, our last one on this slide, I'm going to subtract the 52 to the other side. 4 minus 52 is negative 48. I'm going to divide by 4 on both sides. Negative 48 divided by 4 is negative 12. And then I'm going to do the square root on both sides. And that's over here. That's going to make it just x plus 5. Now, I skipped a couple of steps over here, so I'm going to write them in, but basically I just said, okay, that negative means that there's going to be an I. 12 is 4 times 3, which means this should actually be a 2 I squared roots of 3. That's what happens when you type things up too fast. And then I need to subtract this 5. So instead of a positive, it's going to be a negative 5, plus or minus, that should again be a 2 I squared roots of 3. Okay. All right. And the last thing that we're going to talk about today is how to add and subtract complex numbers. So all you have to do is add the real parts together. Those are the regular numbers. And the imaginary parts together. Those are the coefficients on I. So for example, this one is 7 minus 3 because those are my two numbers without i's. And then I'm going to take a different color, 8i minus 9i. So don't forget that this negative applies to the 9i as well as the 3. So 7 minus 3 is 4, 8 minus 9 is negative 1. And you can put that 1 out there if you want. I'm not going to any of my answers. So you're pretty much just combining like terms the same way you would with their x's. Okay? Coming over here to the right, looks super complicated. Start by circling all of the numbers that don't have an I with them, which is these two. Negative 4 plus negative 7 is negative 11. And then you're going to do the same thing, but with the ones that do have an I. So 11i plus 6i is 17i. 17i minus 20i is negative 3i. So you're just adding and subtracting the numbers the normal way. And then when you write your answer, we're going to put the negative 11 first because it's the real part. The I part goes second. Here's what I want you to do on the assignment today. Okay, let me clear this off. A through L and Y through AD. A through L, Y through AD. It should be only things that we just talked about today. Tuesday's assignment is going to be the rest of them. And I will also post this as an announcement on Classroom.